Hi everyone, I'm Rosemary on behalf of GenScript, and today we're interviewing iGEM Thessaloniki. iGEM Thessaloniki, can you please tell us more about yourselves and your team's project?
Yes, sir. Dimitris?
Of course. My name is Dimitris and I study physics. I'm in my senior year and I'm a member of the lab.
I'm Anastasiou and I'm a molecular biologist and geneticist, and I'm a member of the wet lab. So as you can see, our team's project is related with pancreatic cancer early diagnosis, but before we talk about our project, you should meet the rest of our team members. As you can see, we are an interdisciplinary research team with members from biology department to pharmacy department and even to electrical and computer engineering departments from the Aristotle University of Thessaloniki, one of the biggest universities of Greece. This is our team's PI. During our journey in the contest, we have gained a variety of medals and awards, such as the Best Therapeutic Project in 2017. But let me tell you a little bit more about this year's project. And pancreatic ductal adenocarcinoma, which is the most common type of pancreatic cancer. According to the World Health Organization and the data from 2020, pancreatic cancer is the 12th most common type of cancer, but when it comes to the number of deaths, it's the seventh deadliest type of cancer, with only approximately just 5% of patients surviving 5 years after the diagnosis, which is a very low survival rate, mainly due to the late diagnosis, because in the early stages, patients don't experience any symptoms, and the currently available diagnostic methods aren't accurate and sensitive enough. So this year's goal is to develop METIS, a microRNA expression toehold investigation system, in order to achieve a pancreatic ductal adenocarcinoma early diagnosis in stage 1 and stage 2, with low-cost and non-invasive methods using urine microRNAs as biomarkers, with high specificity and high sensitivity, in order to increase the 5-year survival rate from 5% to 40% by increasing treatment effectiveness.
And this goal will be achieved through toehold switch technology. Toehold switch is a synthetic riboregulator that allow the express of a repressed gene. And in our case, it's the GFP, the important gene of GFP. Toehold switch recognize a trigger RNA that in our case are microRNA, and upon binding the complex conformation allow the ribosome to bind on RBS and the initiation of translation occur. We synthesize and analyze the toehold switches with software of NUPAC and Vienna RNA. The next step is the experimental procedure that will result in a standard curve of initial amount of microRNAs and fluorescence. And after quantification of fluorescence, we aim to develop a kit which will have a PCB Arduino microcontroller that will quantify fluorescence and will have as an output the initial amount of microRNA of the sample of the patients. This is our project timeline. First, we are the big data analysis and the primary structure and the design and analysis of toehold switch with Vienna and NUPAC, and this stage has already done, and we are around the second stage, that experimental procedures. We are now at development, testing the toehold switches and the quantification of fluorescence. And the next and final stage is the development of the device to have this microcontroller that scans on the fluorescence of the samples, and after we have as an output the initial amount of microRNA. This is some of the events we took part into as iGEM Thessaloniki. We can see here, right here, that we took part in entrepreneurship conferences. We have given interviews on TV and radio, and we have meeting the director of Thessaloniki University. An upcoming event that we'll host is a seminar of 6th of June that is a National Cancer Survivors Day, and a series of interviews with National Organization of METIS will follow for consulting our project. Thank you very much for your attention, and we want to listen your questions about our project.
Thank you very much for that exquisite presentation and giving us the details on your iGEM project. It's definitely very innovative and will definitely make a great impact, helping a lot of people with the early diagnostics for pancreatic cancer.
Yes.
So you mentioned in your experimental design that you had in the first stage of your project, you had to collect a lot of big data. Can you tell us more about what compiled that big data analysis?
We have gathered a lot of large data set on patients with pancreatic cancer that is classified with stages, and we saw that our microRNAs that we aim to recognize with our toehold switch system are overexpressed, and this analysis already has done, but we continue to search with the programming language R to study more about the data. Oh, that's all.
And for the development of the microcontroller, can you tell us about what materials and what planning is involved in the development of that?
To be honest, we haven't proceeded to develop and design this device yet, because we want to see if the toehold switches are work perfectly and according to our calculations. But we will, as a general perspective, we have a screen that will scan on the urine samples of patients, and we will see the fluorescence of the samples and determine from the standard curve that will occur from experimental data to the initial amount of microRNA. So we will be sure if someone has pancreatic cancer, adenocarcinoma, or not.
And I also saw that you have been very involved with TV interviews and bringing awareness to your project through the media and conferences. Can you tell us more about what these interviews were like and what subjects or how you're using it to bring awareness to your project and educate the public on the impact that your project could have?
So about the entrepreneurship conferences, I have taken part in one conference. It was mostly about entrepreneurship and not so much about pancreatic cancer. But now we are taking part in a competition, in an entrepreneurship competition, in order to see if we could make a product out of our project. In the meantime, on TV and radio, we are mostly talking about how important is to get tested if you are in the high-risk groups for pancreatic cancer, like if you have diabetes or if you have obesity. And we are mainly focusing on in that area. Mainly this.
And is there anything about your project that you would describe as unique or something that's never been done before?
To be honest, this type of system, toehold switches, has already been studied from a lot of iGEM team. But on the subject of pancreatic cancer, adenocarcinoma, has been done a search with toehold switch system. I believe that our device will have a good result, and we also have innovated the system that will scan and see the first 2 stages of cancer.
And from the wet lab, I think that the unique part of our project is the amplification method that we are trying to combine with toehold switches, because the most papers are referring to toehold switches, but not how we amplify the microRNA before in order to be insensitive techniques. So this combination, we think that makes our project unique.
Is there anything else you would like our audience to know about your project?
I think no, we are in the current stage of modeling, except all this interaction of RNA interaction with the chemical mass action kinetics from dry lab perspective, of course. And we aim to make a software that maybe is more generic than a microRNA system, to design more than a microRNA.
And if someone has any questions or even some comments, we would be more than happy to hear them.
Great. Well, iGEM Thessaloniki, thank you so much for meeting with me today and telling us more about your project. Definitely believe that this could have a tremendous impact on the diagnostics for pancreatic cancer and make a more accessible diagnostic tool.
Thank you very much.
Thank you very much.